Hello and welcome to Aughton Math. In this edition of Aughton Math, we are going to work on some problems solving linear systems algebraically using two methods, one a substitution method and the other elimination method. So we got four problems due. Let's get started. Let's start on 1 and 2. Okay, so solve the systems of equations using substitution. So we want to solve for one variable in terms of the other. And then we want to substitute that value back into the second equation. So we have the first equation and the second equation. Let's go ahead and solve for y in this case. It doesn't really matter if we solve for x or y in terms of y or x. The answer will come out the same. We'll just get an answer first for one variable or the other, depending on which way we do it. So let's just say that in this case, x plus y is equal to 4. We're going to solve for y in terms of x. So I can subtract x from both sides, and I get y is equal to 4 minus x. All right, now I'm going to use this value for y. I'm going to substitute 4 minus x back in for y, and then I'm going to solve for x. So in the second equation, I have 2x minus 3 times 4 minus x, because now I'm substituting y back in, or 4 minus x back in for y. And that's going to be equal to negative 2. So let's simplify the equation. I have 2x, and be careful here, now you're distributing negative 3 across 4 and negative x. So I have negative 3 times 4, so it would be minus 12. Minus 3 times minus x would be plus 3x is equal to negative 2. So I have 2x plus 3x, that's 5x, minus 12 is equal to negative 2. Now I'm going to add 12 to both sides, and I have 5x is equal to 10, and x is equal to 2. So once I've found the value for one of the variables, and I'm working with a system of two variables in this case, and a later chapter, in two more chapters, we'll talk about solving systems of three variables. But when I have an answer for just one variable in a two-variable system, all I need to do is substitute that value back in and solve for the other variable. So if I substitute 2 back in for x, I get 2 plus y is equal to 4. And we can figure out that y is also going to be equal to 2 as well. Okay, so that's the first problem. Let's take care of the second problem, and we're going to erase all of our work here. So we're going to erase all this, and we're going to start on the second problem. It'll give me a moment to create some space. Okay, in the second problem, we're going to solve for, we're going to solve for x in terms of y, and we're going to use the second equation in this case. I'm going to subtract 2y from both sides, and I have x is equal to 4 minus 2y. Now after a while you kind of get an eye for which one is going to be easiest to manage. Either way, depending on how you solve the equation for whatever variable you choose and whatever equation you choose, it might be more or less difficult if you are working with fractions. So I can see here that I'm not going to have to work with fractions by setting x equal to this value 4 minus 2y and then solving in the first equation. So I'm going to substitute in 4 minus 2y in for the values, or the value of x in the first equation. And I get 4 times 4 minus 2y plus 5y is equal to 21. So I'm going to distribute the 4 across the parentheses, and I have 16, and remove the parentheses. 16 minus 8y plus 5y is equal to 21. Negative 8y plus 5y leaves me with 3y, negative 3y, and I have 16 minus 3y is equal to 21. Now I'm going to subtract 16 from both sides, and I get negative 3y is equal to 5. Okay, then I divide negative 3 by both sides, and I get y is equal to negative 5/3. Now I have my value for y. I'm going to substitute that value back in. Let's work with the second equation. And so I have, and we'll work up here, x plus 2 times negative 5/3 would be negative 10/3 is equal to, and I'm going to change 4 to a fraction so that I can add the 10/3 simply without having to worry about my denominator. So 4 is the same as 12/3, and now I add negative 10/3 to both sides, and I end up with x is equal to 12 plus 10/3, or 22/3. So there are my values, 22/3 for x, and I have negative 5/3 for y. Okay, moving on, we're going to solve a system by elimination. So I have two problems. X minus 2y is equal to negative 2. 3x plus 2y is equal to 10. So remember, the strategy is to align the coefficients for one of the variables so that one is negative, it's the same value, and one is positive, the same value. So you can see that the book has already done that for us in the first example for number 3. And so what you're going to do is you're going to add those values together, and let's see what we get. So let's draw a line. My computer's being slow, so bear with me here. I'm going to add these values together. So I get 4x plus 0y is equal to 8. So again, I'm adding top and bottom. 4x is equal to 8, so x is equal to 2. Now I can use the substitution method to solve and finish this particular problem for y. So I substitute 2 back in for x, and I get 2 minus 2y is equal to negative 2. I subtract 2 from both sides, and I have negative 2y is equal to negative 4, or y is going to be equal to 2 as well. So I have y is equal to 2, x is equal to 2. Those, that ordered pair is my solution using the process of elimination. Okay, so I'm going to tidy this up again, and we're going to work on the second problem. Let me erase this all. Okay, in the second equation, and again, the book has set this up for us nicely. In most situations, you're going to have to multiply by some constant value across the entire equation in order to get a solution, or in order to use the process of elimination so that each of the coefficients is the same. So let's take an example here. Let's just say that this were 2x. Let's just take this example, okay? And then we'll go back to the original example. Let's say that this is 2x plus 3y is equal to 15. And now we're gonna eliminate the x variable just for fun. So what I'm going to do is I'm going to multiply the first equation, 2x plus 3y, by 2. So I get 4x, and I'm multiplying 2 by every term, plus 6y is equal to 30. And the reason why I want to do that, again, is because I want to add one of the variables with the coefficients to another variable with the same coefficient in order to get a result of 0. So I can see here that 4x plus negative 4x is going to be equal to 0. And so I can use the process of elimination then to solve for y. So I end up getting 0x plus 9y is equal to 27. And then x is equal to 3. And I can use this value for 3 to substitute back in and solve for y. All right, so now we're going to do it the way that was originally stated. But I just wanted to give you a flavor for what you needed to do in the event that the book is not so nice to you. And it doesn't give you coefficients that are perfectly aligned so that they add up to 0, which is going to be this case in the second problem. So 4x plus minus 4x gives me 0x. 3y plus 3y gives me 6y. And that's going to be equal to 5 plus negative 3, which is equal to 12. Divide both sides by 6, and I get y is equal to 2. Now, with the value of y is equal to 2, I substitute that back into any equation. And so I get, let's try the first one. So I get 4x plus 3 times 2, which would be plus 6, is equal to 15. 4x subtract 6 from both sides, and I get 4x is equal to 9, and x is going to be equal to 9/4. So let's see if we did that correctly. All right, so I took 2 and I substituted it back in for y. So I have 4x plus 6 is equal to 15. 4x is equal to 15 minus 6, which is 9. X is going to be equal to 9/4. That's correct. So I have my values of 2 and 9/4. I know that looks like a 14, but again, that's 9/4. All right, that's it for Otten Math, substitution and elimination. If you need more help, go back and take a look at the lesson on this topic. We're going to move on. So join us, Chapter 3.3, Solving Systems Graphically, solving inequalities, linear systems that are inequalities graphically, and the next section of Otten Math.